I'm Kelsey. I'm my mother's son. She gave me that name. She also introduced me to tech. It was my mom working as a single mother on the dining room table, teaching herself how to touch type so she can get one of those jobs that come with healthcare. She introduced me to the game of learning to get what you want, how to achieve and put technology to use to solve real problems. Problems so you can help your family. That's what technology is about. It's about people leveraging and pushing themselves forward to get what they want out of life. My mom was my hidden figure. The path to serverless, for me, I guess, began at that time. How do I build a platform where people can just focus on using the technology to get what they want? This is a scene from Hidden Figures. It's the best tech movie you will ever see. The interesting thing about this scene is that at this time, there's a race to get a human in space, and this team, represented by Katherine Johnson, played by Taraji P. Henson, she's this brilliant mathematician, and think about this, we're going to space for the first time, and this is incredibly a new problem. But what's amazing about this particular scene is that they believed that new problems required brand new solutions. People ignored the past and got nowhere. And then the light bulb went off and said, hey, maybe it's a new problem, but maybe an old solution is the answer. And that turned out to be the trick. Something written decades previous was the answer to solve and move them forward. While Katherine Johnson is depicted as the main character in Hidden Figures, one of my favorite characters is Dorothy Vaughan. Now, she represents in her team the human computers. These are the people doing these calculations, flight trajectories. How do we get a person not only to space, but we got to bring them back, right? It's easy to launch something. It's hard to bring it back. And that's what tough engineering is all about. Now, her whole team was being threatened by new technology, right? Human calculators, human computers can only go so fast. And IBM shows up. Oh, we can do what they do. Now, to her advantage, the system wasn't ready to go. All new systems have problems, okay? Now, she could have taken a back seat and said, hey, it can't do what I can do. No computer is going to replace my job. No amount of automation can replace what I do. She just knew she had a little time until they figured out how to get this machine working. And instead of worrying about losing her job or comparing the paper and pencil versus the computer, paper and pencil is superior to computers. She didn't go about it that way. She did what any respectable engineer would do. She taught herself Fortran.
Oh, yeah.
Look at all the Fortran programmers, like, I knew it would come back. So I stayed on it and stayed focused. Fortran is still here. One of the original programming languages. Don't you dare call it legacy. It's a classic programming language. Many of you are probably being paid because of Fortran, so respect it. And the interesting thing about her teaching herself Fortran, that's interesting all of its own. It's very inspiring to me. But here's the key. Not only did she teach herself Fortran, she went back and taught the whole team. If you're ever confused about what a 10x engineer looks like, well, folks, there you have it. Now, in honor of all of these hidden figures, you probably work with some. There are amazing things people can do if you let them focus on being their best. So why is this serverless thing interesting? It's all packaged up in all of these buzzwords. Everything is serverless. I bought a serverless microwave the other day. It's the thing that pushed me over the edge, whether to get the blue one or the red one. And I really went with the blue one because it was serverless. It's the only way to do that decision. So in honor of them, what I'm going to do is how do we should think about our current platforms to make them easy to use? There's a lot more work to do. Kubernetes is a platform for building platform. It is far from the end game. So we're here as platform builders. But we've got to take a look at what the end game looks like. Last year I talked about CI/CD, but we're going to just drill in a little bit more about the underlying platform. So I'm going to switch to my laptop. Y'all weren't going to leave here without some live demos. Come on. So this is what I want you to envision. Dorothy Vaughan is with us. She's no longer with us. She passed, I believe, in 2008. But let's say this genius shows up, and she wants to take humans to Mars. And she's working on complex calculations to do so. And she shows up, and she says, hey, now I'm nowhere as smart as Dorothy. So my mathematical equations are going to be much simpler, okay? We're going to be calculating momentum, right? This is a simple one because I looked on Wikipedia and I could understand it. Mass times velocity, and then you just kind of put the symbols together and look like you know what you're doing. So that's what we're going to run with. And she shows up and she says, hey, I got this calculation. I just want to run it on the entire data set. And I know what you're thinking. This is a perfect opportunity to teach her Docker and Kubernetes and all the cloud-native technology. Space can wait. And this is what we're essentially doing. People want to focus on the business problem or the task at hand. This is the task at hand, and we get real confused. Don't get confused, folks. There's a much bigger picture at play where you work, what you're building, and what you work on. Now, it's nice that we have all these tools, but remember, they're meant to allow people to solve this problem. Now, look at this particular set of code. So this is that whole function thing. There is no HTTP library that I could find in Fortran. Now, you would say someone needs to modernize this application, right? What does modernize mean? Most people are just throwing JSON around the wire. That's chaos. If that's modern, I don't want that. Look at the simplicity of this. This is actually simpler than the Go code that I tried to write. So I'm going to walk you through what it does really quickly. Sets up a couple of variables to hold some data. So we have mass, velocity, and momentum. And then what we are doing is we're setting up the format of how I want to spit this out. So this would be a CSV file. We're going to take these floats, and we're going to spit out some CSV. Then I'm going to enter this loop. Standard in, I'm going to read, and then I'm going to extract the values from the file that I read in and assign them to mass and velocity. And I'm going to call calculate momentum, and it's going to return back to me the momentum. And then I'm going to write to standard out. And that's it. That's all I need to do. That's all the business logic that's required. Everything else is noise. Even setting up an HTTP server, that's not about the task at hand, actually. That's just infrastructure. It's not just about Kubernetes, the cluster manager, and containers versus, that's not important. This is the business logic. So let's reduce that. So even in the Kubernetes world, we can learn that it's not just about adopting sidecars to ease the burden. We should also be building application frameworks that live in those containers so people can focus. Now, you're like, how the hell are you going to get this into Kubernetes? So I have to build a little shim. And I have this little shim called runtime. And that runtime will do all the heavy lifting with HTTP, read a message, maybe pull something from an object store. I'm going to show you how it works. And then one thing that's really nice, and this is where I think Docker did a great job, was introducing the world to a way to think about how do we build this. How many people have a Fortran compiler on your laptop? 3 of you work at the local bank. I see you with your hands up. Hats off to you. But most of you don't. I don't even know where to get one. Luckily, Fortran had a recent release just 2 weeks ago. Fortran 2018 was released. That means Fortran is newer than Go 111. So you all need to get with the times. Get some of that sweet Fortran going. So here I'm building this shim. I don't want to hide anything from you. I'm just going to call it runtime. So it's going to be the harness to allow this to be retrofitted. We're retrofitting. There is no digital transformation. Marketing budgets just blew up. God damn it, we just opened a full-page article. There's nothing to transform to. We're still dealing with basic ins and out. Stay focused. And then we build Fortran. Actually, it was easier to do static linking in Fortran, to my surprise. And then I'm doing this pattern that has arisen over the years. Instead of shipping build environments, those 2 layers at the top, those are base images. I'm bringing in a whole operating system, but I'm only doing that so I can actually compile the application. At the bottom is where I copy the 2 binaries I care about. Bootstrap, this will handle the heavy lifting, and then momentum, the function to do the calculation. And then I'm going to stuff them in containers. And I'll tell you, I thought the container was the end-all, be-all. The problem is the container doesn't really make it easy to compose things at runtime. Sure, you can compose things at build time, but not necessarily easy to compose this kind of thing at runtime. You know what I wish I could have done? I wish I could have built the Fortran binary in one container and the harness in another so I can use it for other things and then combine them at runtime. That's not easy to do with containers. We assume that they always run. There's a lot to learn from the serverless community who is taking a different look at this. There's no competition, different looks, worthy of study. So we take this, and then we wrap it up in a bunch of YAML, and we push it to Kubernetes, and Kubernetes does an amazing job of making this run. And let's take a look at that running now. All right, so we have this pod. It's been running for a little while, 4 hours, so this is what it's like when you prepare your keynote in the morning, right? So this is up and running, and what I want to do is I want to upload a file. So the way this works is I have a trigger on a bucket that will go through this pub/sub thing, and then pub/sub will push to this HTTP endpoint. So this is another thing that I found valuable in the serverless world. Things get a lot easier when you can just respond to some events. The event message type is much clearer. You can do things like scale to 0 and only scale back up when the event shows up. You could do this in Kubernetes. There's a whole community of people working on it. Project Native and all of these fast frameworks, they're attempting to give you this capability, right? So now that I have this thing pointing to my Kubernetes cluster, what I can do now is upload an event to trigger this. So we're going to upload some files, and we're just going to take this input.csv, and if I upload it, that should trigger an event, right? And we'll just hide this. And if this works, come on, mouse, people are watching. All right, if this works, we should be able to come here, hit refresh. Yes. And then we get some output. So those are all the momentum calculations for these 2 inputs and outputs. And yes, it takes milliseconds to complete this puzzle, even on top of Kubernetes. And most people don't understand that you're probably using a bunch of serverless architecture components already. You notice pub/sub is not running in my cluster. The object store is not running in my cluster. There is no battle between serverless and Kubernetes. It's all about how much of this mindset do you want to adopt. And most people I see using Kubernetes are leveraging managed services across. So if you think about this, you're on some scale, and I think we're going to continue there, where everything that we're working on, everything we're building, you or someone else will be able to provide a consistent, clean, easy-to-use interface where I don't have to worry about it. And if that's not your goal, you're going to have a problem. So it works in Kubernetes. Great. So now what is this delta between using a serverless platform? And I go on and I listen. What is the gold standard when you think about serverless? Someone say it loud. What was it? Someone said Lambda. Don't matter where you work. People have spoken. There's a lot to learn from this platform. Why do they make it easy? Because you get to focus on the function. So let's tease that out and learn from it. Put your vendor t-shirts down. It's okay. Don't tell anyone if you don't want to. But you can learn. So we look at this and say, hey, what's so nice about this? What's the delta? And I remember early on, I'm like, hey, how are those zip files working out? It's like, Kelsey, we don't need containers. And I'm like, well, containers are different from Docker versus what you package. So what we're arguing about is tarballs versus zip files. Like, Kelsey, it's not that easy. So let's try it. So as a good engineer, after you read the blog post, your next step should be to validate what you read, okay? So how do you validate? So here's the thing. I got this stuff in a container. We saw the container image I built, right? But the price of admission to Lambda is zip files, okay? And Lambda doesn't understand Fortran. But I want to see if I can reuse the functions that I have without rewriting the code. Now, is this possible? I don't know. We're going to find out. We're going to find out. So here's the thing. That container image that I'm running, I'm going to show you the layers. This is a really cool tool called Dive. It lets you bounce into the layers of your Docker image. It pulls it down, lets you walk through the layers. You can see I only have 2 layers. One binary is the bootstrap binary, and the other binary is the momentum binary. It's kind of hard to see on the screen. So my layers are pretty simple, and this is a great pattern if you do have a language that you can do static linking. We do not need to ship entire operating systems when we're leveraging containers. So this has been the best practice. So what I'm looking at, if I were to flatten this out, get rid of all the Docker metadata, I would have a tarball, folks, a tarball. So ideally, I should be able to extract these binaries out of the tarball. So let's try that. So I wrote this little tool, right? It's called Diana. You'll know why soon. So Diana, if you give it an image name and you tell it what you want to extract out, it will go and pull the binaries out of the container so we can use them somewhere else. So let's try this. Without changing any code, I have this bootstrap binary, and I have this momentum binary. So we extracted 2 files from a tarball, and Lambda says, give me some zip files. So recently, they announced the ability to do custom runtime. So I got to thinking, could I not just reuse the bootstrap command to be the runtime for Lambda? And they also introduced layers so that way I can share this code. Now that's something we don't have. We have Docker layers, but not the same composability. There's a lot to learn there. And I can take that function and use my custom runtime interface. I just got to put them in zip files. So I'm going to walk you through what's required. And I'm literally serious here. Zip runtime.zip bootstrap. Don't make this too complex. That's what it is. Well, that's it. And if you want to do the function, it's the same thing. You're going to do function.zip, and you bring in momentum. And then you're done. 2 zip files. And version them, put them where you want. So now that we have these things, the next step is to upload them to Lambda. So we're going to do this custom runtime interface. Now the goal is I should be able to leverage these binaries as is by uploading them to Lambda with no code changes, and then point the URL there, and then it should work. And you'll notice another thing that's about serverless that's nice. Doesn't matter who's hosting what. It should work across platforms. So I'm going to still use Google Cloud Storage. I'm still going to use PubSub, and I'm just going to fire the event to the other side. Let's see if we can do this. All right, so we come to the Lambda dashboard. So the first thing you do here is obviously reload. That's what you do with these things. So I log in, and what we're looking at here is I can create a new function, or I can upload a layer. So here we have this Fortran runtime. Ideally, if I upload another zip files, maybe I'll do it really quickly here. This is when you should count your winnings. So I'm going to publish a Lambda layer. And what it should do is take this input zip file and upload it to Lambda and give me a new version. So you see there, version 12. We currently had version 11. I'll hit refresh here. Now we have version 12. So now we have the thing that we got from the container. And now the next thing is we have to upload a zip file. And we come here, and we just upload the zip file right from your laptop. So we'll take function.zip, and we upload it. And then we hit save. I'm nervous about doing that from scratch, but here we go. And I have some environment variables I won't show you, and I also have an API gateway set up and a custom domain name, so that way I can just leverage this domain and point things there. So let's see if we can make this work. So we'll come here. I don't know about you all, but I'm nervous as hell. So we'll come over here and we'll say Lambda. Now this is on you, AWS. You didn't make it work on purpose. Nah, it's kind of your cloud. All right, so we hit save here. We have this URL in place. I'm going to delete the results bucket. All right, here we go. It's your chance. It's your chance. All right, let's look at the logs, make sure nothing's funny. Nothing's fishy. We'll sign in. All right, yeah, whatever. So we'll come over here. Man, there's this thing called single sign-on. It's dope. We'll click on logs. You better not ask me to sign in. Okay. All right, so we have no logs. Now here's the test. Can we do it? Straight from the container, straight into serverless, same infrastructure around it. We'll upload a file. I'm gonna slow down too. You guys are like, come on, do it. The input file goes. We'll replace the existing object. We'll see if we got some logs. Oh, we got some logs. Well, hold on. All right, let's see. And then let's see if there's a result. You guys better clap your ass off if there's a result in here. My takeaway is this. These are just tools. Focus on the big problem. The most important tool is sitting right there in the chair. Figure out which ones make sense. You leverage them. Put your hands on the technology. You're an engineer. Act like one. Thank you.